Done.
Okay, written.
Yeah.
First 2 points.
Not yet.
Okay. So in this one, the third point I can say it can remain positive, right? And it can never be zero. Can't be zero or negative,
Okay.
right? And this one, it can be positive, negative, or zero. Yes, Ram is written till here.
Can you go up?
Achha, okay. Now, last point. Distance can be equal to displacement. Of course, in some cases, distance and displacement can be equal. All right. In which case? In which case? In linear motion. You know what is linear motion? In linear path. See, bache.
Yeah.
Here in this case, if my car, suppose my car is traveling from here to here, right? In this case, suppose it is 100 meter. So in this case, the distance is also 100 and the displacement will also be
100.
yes. So I'll be mentioning it specifically in linear path. Okay.
Yeah.
All right. Now in the next one, displacement can be equal to distance or it's lesser than the distance. Okay.
Yeah.
Or it's lesser than the distance. Why lesser than the distance? Because distance is always the total path, whereas displacement is the shortest length, right? So there is a possibility my displacement can be lesser than my distance, right? Write it.
Yeah. Done. Ma'am, I'm done.
Written, understood this example? Everything
Yeah.
is clear till here? Shall we go ahead with the question?
Okay.
All right. So, right, a body travels. Acha, did you do the question I've sent on your web portal?
The after class assessment or something.
Okay.
That one.
Hmm.
Yeah, I didn't do it because I had to stay back in school.
Acha, okay. But you have to do it because your dashboard is being maintained, right? How many classes are you joining? How are you responding in the class? How many assessment and assignments you are taking, right? Okay.
Okay. And also, I don't have time to do it because I have a lot of work from school.
Okay. Acha, it's fine. Whenever you are getting time, I am hardly providing you 2 to 3 questions because it's
Okay.
important to practice in physics, right, bache?
Yeah.
Because only then your calculation will be very faster and you'll be able to attempt all the variety of questions.
Okay.
Okay. So you get time,
Mm.
please do that because it's
Okay.
important.
Okay.
So like for example, this student has done. See, okay, you have to submit your assignment like this.
Okay.
Anyways, starting from point A, now calculate distance and displacement. All right. So in what shape my path is? Semicircular. Okay. What is the radius? 10 meter. One point is A, the other point is B. Calculate the distance and the displacement. Done.
Can you explain the question a little bit further?
All right. So what kind of path am I having this time?
Semicircular.
Semicircular. This is semicircular, right?
Mm.
Can you see it? This is semicircular. Yes or no?
Yeah.
Just a second. Okay. So suppose this is my point A and this is my point B. Correct?
Yeah.
This much is the radius. Radius is always taken from center till the circumference. Yes or no?
Mm,
And all of these things are already given in the question. I'm just putting it diagrammatically. Now a body travels in a semicircular path of radius 10 meter, starting from point A to point B. That means my body has started from here, then it is going till here. Okay. What will be the distance? How will I calculate the distance?
calculating the circumference.
Exactly. What is the circumference of a semicircle?
Pi r.
Yes, excellent. So the distance will be equal to circumference of semicircle. This is what we have to mention. Circumference of semicircle, right? Which is pi into r. Okay. Put the value and calculate it. And what will be the displacement?
20 meter.
Very good. Displacement is simply the shortest path. That will be the diameter or 20 meter. Calculated. Displacement will be equal to the diameter, which is 2 into 10. Don't forget the units. All right.
Okay. Yeah, I'm done.
Yes, now tell me what is the distance?
31.42.
Correct. What is the displacement?
20 meters.
Perfect. Understood?
Yeah.
So now shall I go to the next topic?
Yeah.
All right. I have given these kind of questions only in your assignment, okay, for previous class.
Okay.
Anyways, so the next is about uniform and non-uniform motion. Uniform and non-uniform motion. So uniform motion is when a body is traveling equal distance in equal interval of time. Okay, let us write it. All right. So suppose there's this body, there is my car, which is traveling, suppose 20 meter in 10 seconds, right? So what is its speed?
10 meter per second. Wait,
Hmm?
2 meter per second.
Yes. So its speed is 2 meter per second. Good. Now in the next part, like my body has traveled now. My body has traveled 40 meter in 20 seconds. What is its speed?
2 meter per second.
Again, 2 meter per second. Okay. So like it is covering equal amount of distances in equal intervals of time. Got it?
Yeah.
Understood? So what kind of motion will it be?
Uniform
Uniform
motion.
motion. Okay, there is uniformity. Now we'll be asked to make a graph of it, okay, of uniform motion. We can be asked this in MCQ question or maybe in 1 markers. So it is important to identify on the y-axis. On the y-axis, I'm keeping my distance, okay, which is
Okay.
denoted by S. And in the x-axis, on the x-axis, I'm gonna keep
Time.
my
Time.
yes. Okay. Now straight line, uniform. Okay. This is the graph for uniform motion. Understood?
Yeah.
Made it?
Yeah. Done.
Okay. So what is this line called? This is called the slope. Okay. What is this line called? This is called
Slope.
slope. Slope of ST, slope of distance time graph gives us speed, right?
Yeah.
Okay. Anyways, the next part is about non-uniform motion. So tell me, can you guess what is it?
Traveling unequal distances in equal
Eh,
intervals of time.
Yes, very good. Non-uniform, write it. Non-uniform motion when the body will travel equal unequal distances okay written. So now in this kind of motion, in this kind of non-uniform motion, my body will travel unequal distances in equal intervals of time, because the time will remain same. Obviously distances is, it is covering unequal parts. Okay, so this is non-uniform motion. Now non-uniform motion, it can be like my body is covering, my body is increasing in its speed with time, right? Or either it is decreasing its speed with time. In these two way only non-uniform motion can occur. Yes or no?
Yeah.
All right. So first, in first case, what do you think? This, it is the increasing one or decreasing one?
Increasing.
Very good. And in the second one?
Decreasing.
Yes. So let's mention that too. You have made the graphs, right?
Yeah.
So now in this one, in the first one, I'm gonna say continuous. Continuous. Yeah. So basically in the first one, what is this accelerated non-uniform motion? What is it? My speed is increasing with time. Okay.
Yeah.
And in the second one, my speed is decreasing with them. That's why I'm calling it deceleration. Okay, easy.
Yeah.
Written both of these, description of the graph.
Yeah.
So now this non-uniform motion is of two types, as we have discussed already. But this is the distance time graph. This is the distance time graph. We also have velocity time graphs. We also have acceleration time graphs. Okay. So in these kind of graphs, we should know the slope. What does the slope gives us and what does the area gives us? When it comes to distance time graph, we don't talk about the area, but we talk about the slope. And what does the slope give us? Speed, right?
Yeah.
Now now let's discuss about what kind of non-uniform motion we have. I have already briefed about it. First is the accelerated non-uniform motion, and one is the
Decelerated
very
uniform,
good
non-uniform.
decelerated non-uniform motion. So now I'm going to make the velocity time graph of it. That means in the case of my accelerated motion, I will be showing my speed is increasing with time, right?
Yeah.
Right. And in the case of decelerated, my velocity will be decreasing with time. Okay.
Yeah.
So let's write non-uniform motion is of two types: accelerated non-uniform motion and decelerated non-uniform motion. Now the accelerated one is basically when a motion of a body increases with time, right?
Yeah.
The body increases with time. Now on the y-axis, this time I'm taking velocity. Okay. Is increasing. Okay.
Yeah.
Now in the second one, when motion of a body, tell me.
Decreases over time.
Yes. Body decreases with time. All right.
Yeah.
So how will I make? Can you try? How will I make the graph?
Like drawing the distance, the x-axis,
No,
y-axis,
no, no.
and
How will I make the VT graph
uh,
for decelerated?
up to down.
Very good. Excellent. Like this. Right?
Yeah.
This is what you were saying. Just a second. Let me mention it correctly. All right.
Yeah.
Now let us talk about speed in detail. Okay. What is the average speed? What is the condition of speed in case of non-uniform motion? All right. And conversions, which which I've taken a test as well. Remember in your trial, we
Yeah,
had a question now.
yeah,
Conversion of units. In this
yeah.
topic, I'll tell you. Okay. So what is speed? Define speed.
Define speed,
Hmm.
the rate of which a body is going in motion.
Basic definition according to the formula.
Oh, speed is distance by time.
Yes, speed is distance covered by time taken, right? What is the SI unit of it?
Meter per second.
Very good. And if the body is executing uniform motion, then what will be my speed?
Uniform motion.
Hmm. My speed will be constant, right?
Yeah, constant.
Just like I've given you example of 2 meter per second, remember?
Yeah,
Okay. So speed is distance traveled by time, the basic definition which we have studied in our junior classes as well. Remember? Now we got to mention it with the help of the letters which we use to denote it. Okay.
d
Time
by
we
t.
all know, right? Time we all know we denote it by small t. Distance by
D
uh no,
as
yes. Speed by v. Okay.
oh, because like when in other class, like smaller classes, we learn S equals D by T.
Yeah, in junior classes, we used to write it like that. But now, in this chapter, we are going to study about the equations of motion. You must have heard about V is equal to U, V is equal to U plus AT. In that case, in these scenario, we use specific letters which are universally accepted for distance, for speed, and for time. Time is
Okay,
very clear, small t. But for distance, we use S. So don't
mm,
confuse it with D. Okay?
okay,
Are we done?
yeah.
SI unit is meter per second. We already know. Next point. If a
Um,
body traveling with, if a body executing uniform motion, then Okay, it will show different values,
Okay.
right? In non-uniform motion. Now the last point. Acha, till where in your school this chapter has been completed?
No, in school we only have like 2 periods for each of the science subjects, so it's hard to complete the portion quickly.
Acha, all right. So this chapter hasn't been started yet.
No, it started and we stopped till like what, I think velocity or something.
Acha, okay, okay. So did you understand anything in school?
Yeah, somewhat.
Acha, acha, okay, nice. Do they make you practice the numericals as well?
Yeah, after teaching the,
Concept.
yeah, then they'll give a few questions.
Acha, are you able to solve these questions now? The
Yeah,
one I'm doing in class, you are able to understand them, right?
yeah.
Okay. Yes, bacha, tell
Again,
me what. Hmm?
yeah, again we use V equals S by T.
Can we,
Do we still use S by T again, the same one?
for average speed?
Yeah, like the same thing, like,
Here in this case, it's not necessary to mention it in the case of average, okay? But because average speed, you will be writing it like this: total distance upon total time taken.
okay,
This is average, but don't write it. I'm just telling you. For in higher classes, you're gonna study about dv by dt. Like this. What is d like s? The differential parts. Okay, that will you study in the higher classes. The difference between delta and the difference between this d part. Okay, so that's why I've written without any letters this time. Average speed is equal to total distance traveled upon total time.
okay,
Okay. In higher class, we'll study about, in detail, average speed and instantaneous speed. You will learn about instantaneous speed too. Okay.
okay.
So average speed, what does it? Acha, just read the last point once.
Um, for non-uniform, average average speed will describe one single value of the speed throughout the motion of the body.
What does it mean?
Like even if like the values are not in uniform, it will still show one value if you use average speed.
See, my body is moving in non-uniform motion. It is covering unequal, right? It is having different values of speed. Yes or no?
Yeah,
Because
yeah,
it is in non-uniform motion. Now, if I have to consider the overall motion it has covered, then what I'll do, which value will I find? This is the speed, or this is the speed, or that is the speed. Which speed? I'll basically take the average of everything and then we'll call it as the average speed. Okay?
yeah,
Because since it is having different speed, in the case of uniform motion, we already know it is having a single speed only, be it in any path, right?
yeah,
So for non-uniform motion, we take average speed. Got it?
yeah,
Written?
yeah.
Can you explain me the last point now?
Hmm. Like I understood it, but I don't know how to explain it properly.
It's okay. You can try it. You
It's
can
like
you be my teacher for the next 2 minutes? Yes.
I'll
Please tell
try
me.
saying it's like when there are when an object is moving in non-uniform motion, there'll be different values and different speeds that are being traveled. So instead of choosing which one to take, we can just take the total of them and find the average speed.
Perfect. Perfect. We'll simply take the total distance and then the total time. Now, for the conversion factor, because after your trial class, I had another trial class with a ninth student and she couldn't do this. That's why I'm making you write it. When my speed, when my speed is given to me in kilometer per hour and I have to convert it in meter per second, then in which should I multiply?
5/18.
Perfect. 5 by 18. Okay. If my speed is given to me in meter per second and I have to convert it in kilometer per hour,
18
I'll
by
be
5.
multiplying it by
18 by
correct. Example, let's write example. Suppose I have been given 72 kilometer per hour. So it will be, it will be
72 kilometers per hour.
72 kilometer per hour I have been given. I have to convert it in meter per second. So
20 meter per
5 by
second.
18, yes. 18 ones are 18, 18 fours are 72, then 4 into 5, 20 meter per second. Now I have been given 30 meter per second converted in kilometer per hour.
It is 102 kilometers per hour.
Hmm.
Or wait,
Calculation.
108. 108.
Yes. Yes. Kilometer per hour. All right. So
Yeah,
conversion factor is clear. Just write it because it will be very helpful in our numericals.
yeah, I'm done.
Okay. So shall I go with the question? Right. Yes.
Is it a car or a train?
Yeah. Well, great. God. Yes. Tell me, what is the average speed?
8.33 meter per second.
Hmm.
I got 30 kilometer per hour or 8.33 meter per second.
30, right? 30 kilometer, because it has been given in kilometer an hour, right?
Yeah, but I
So what is
converted it
the
to
answer?
meter
What
per
is the
second.
answer?
30 kilometer per hour.
Good.
And I also converted it to meter per second.
No, no, no need to do that. Okay.
Okay.
If I am like given in kilometer per hour, na, then I can leave my answer here only. All right.
Okay. Yeah.
So now we gotta discuss what is velocity. Do you know what is velocity? These are like vector and scalar quantities of each other.
It's like speed with the direction given.
Yes, very good. Okay. So the formula for velocity will be displacement by time.
Or
Yes or no?
u plus v by 2.
Q plus V by 2. That is average velocity. Okay.
Oh, okay.
I'm just talking about velocity. So what will be the unit? Don't write it. Don't write, just tell me.
Unit.
Hmm.
SI unit or just unit?
Yes, yes, SI unit.
Meter per second.
Very good. Very good. Okay. So let's write about velocity now. Speed in a given direction. Can I call it like that?
Yeah.
Speed of a body in a given direction. The formula, velocity is equal to displacement by time. Not distance, but the displacement by time. Okay.
Yeah. And for velocity, is it still v or
Yeah. Velocity, we use B. V again, S and T. That is used interchangeably. That is not an issue. Okay.
the displacement is also x?
Yes. Velocity is a vector quantity and its value changes when either its magnitude or the direction. All right.
Yeah.
Done till here.
Yeah.
Now we're going to continue non-uniform and uniform in the case of velocity, and then we're